Kamal, you can start the recording. Assalamu alaikum, everybody. First of all, Eid Mubarak to you all. And today's session, we're going to be, actually today and tomorrow, we're going to be covering a lot of theory and time permits. I really would like to get all the labs completed this week because next week will be our last week. So we're going to be covering a bunch of some advanced topics. All right, so in today's topic, today's agenda is we're going to be covering database services, AWS database services, and also we're going to be covering networking. And at the end, we're going to do our hands-on labs on both the areas. Networking is a very bigger topic here. So I'm hoping that I'm gonna get that complete end to end this week. So so let's get started on it. And so if we whatever the area up to 8 or 8:15, whatever we could cover today, then we're gonna continue on it tomorrow, and we'll see. I mean, how far we can take it by tonight. I have about 20 some slides here. Alrighty, so database services. I will not be going in much detail on the database services. I'm sure that some of you are in Kumail Bhai's class or must have done some DBA work in the past. But those who have not done it or just heard the name before, don't worry about it. Once we're gonna do the lab, the key purpose is to get you comfortable with it. And there are several services Amazon offers in the database arena. So we're going to be covering one or maybe two services, and the rest I really would like you guys to practice on them, or just to take a chance and see how that works and how to set it all up. Okay, so database services, two major categories that we currently have in the market: relational and non-relational. Relational is also the structured. Non-relational is not so structured. That's what we're gonna cover here. And on the networking side, I'm gonna try to run as extensive as possible the network overview, networking 101 for you guys. What is subnetting? What is routing? And how the VPC is set up. What is VPC? VPC stands for Virtual Private Cloud. So it's a network ecosystem that you set up within your availability zone or within your region, and then based on that, it actually engulfs around your entire infrastructure. And then what is Route 53 and what is ELB? ELB stands for Elastic Load Balancer. What is the purpose of elasticity? What is the purpose of load balancing here? And then in the end, we're going to cover auto scaling. What is auto scaling means? That is also another feature of clouds, which is the elasticity. So how to scale up and scale down. So that's what we're going to look into it. And Route 53 is the service that Amazon calls. Amazon actually calls this service Route 53. That is for the DNS or domain name systems. So what is the purpose of DNS names? Like you type it www.amazon.com or google.com. So that is the name, and behind that every name there is a numeric notation which is called IP addressing. So to translate that name like amazon.com, to translate that into an IP address, that is the one of the purposes of the DNS services. DNS stands for, again, domain name systems, because the entire infrastructure that connects your system to that server or anything comes in between, your routers, your firewall, your switches, whatever and whatnot, they don't understand what is Amazon.com means, but they do understand what is that numbering notation means and how to, connect to the next hub or next, router or next switch or next firewall, into that, into the ring. So we're going to be, covering that extensively as well. So databases, as I mentioned, there are two major categories currently in the market. There may be more coming down the road. We don't know. About what, 10, 15 years ago, there used to be only relational databases, but now non-relational databases, they have picked up pace. And because of the capabilities they are offering, so people are, or the developers or the startups and other organizations, they are more comfortable, utilizing the features they are offering, the non-relational databases. So relational databases, they are structured in nature, structured in the sense that they have a set structure. They have rows and they have columns, and the structure of these rows and columns, that is called table. So your data actually resides inside the table, and every column has a different fields and different meaning. Let's say you have a column for name, you have a column for, let's say, column for first name, last name, address, email address, let's say your social number, your credit card number, and all that. So they all, fall under the columns. And rows is a collection of one record that contains, so rows, like end to end in the row. Let's say if I'm at the row number 1, it has my first name, my last name, my email address, my home address, my city, or whatever and whatnot. So, that entire record about me, it resides in the row, not in the single column. So the column contains fields that are common in nature. Let me just quickly go do this for you guys. All right, so let's say I have this table here. So table comprises of rows and columns. So across is a row, okay, and down is a column, okay. So let's say the first field is, let's say the first field is ID number, second is first name, second is last name, let's say email address in the next one, let's say city in the following one, and then let's say the state in the last one. So in this table, what you're seeing here is the rows, which is this piece here. It will contain information which is of the similar type, like let's say ID1 or ID2 or ID3 or whatever the ID type I have here. So sorry, where is it? Come on. So it's ID1, ID2, 3, 4, 5, and so on and so forth. So inside the column here, all the fields that are inside it, they are pretty much related, right? So in the ID field, I will not have my first name, or I will not have my email address or my city or any other information. Same goes in the first name, certain character limit here, last name, certain character limits here, email address, certain format, right? Let's say first name dot last name at whatever the domain, same thing, right? So this goes here. And then city, whatever, the city style is, wherever, city that you live in. State, let's say you are in, US states, any state in the US. So, states are identified here by by 2 characters, let's say IL for Illinois, or NY for New York, or TX for Texas, or whatever and whatnot. So these are the columns that actually define the that specific specific type, which is filled into it. And then let's say I wanted to pull a record. Let me see if I could find a different color here. If I wanted to pull a record number 3 here, so record number 3, it actually is in a row. So I have ID number and then first name.
Faisal bhai, sorry.
Yes.
For some reason on my screen, I'm still stuck on agenda. What about others?
Are
We can. We are
Fine.
We are fine too.
Okay, sorry. So
Yeah, I'm good too.
sorry, Faisal bhai. Go ahead.
no problem.
That's something on my end.
Okay. Okay. So on that row here, you see that row contains the entire record. So the record has my ID number, my first name, last name, my email address, my city, or my state, right? So this entire thing is the record of that specific ID or a specific person or of that specific record, right? So this whole thing in a tabular form is the structured database, or the structured nature of a database, where it comprises of rows and columns. Okay. And the example you see that, if I just pull up Excel here, in Excel, what you see is it has, rows, like row numbers here on the left hand side. You see all those rows and then the columns here. So not a good example, but it gives you at least an understanding. This is how a data is, a data resides, inside the database, inside the structured database. So they have a relationship among them. That's why they call it relational databases. Relation is, like, let's say I have like multiple tables. So, one table has, some relation with the other table, or maybe a third table, or, or if I have, let's say, a single table database, so all the fields, inside it, they have a relationship, among themselves. So that's just, an example of the relationship there. Kamal bhai, are you able to see it now?
Yes, I had to come back in. I'm good.
Okay.
Thank you.
Okay. Non-relational databases are not so conventional in nature, so they don't follow that strict rule or stringent rule of rows and columns, and every rows and every column has to have some sort of values into it. And we're gonna see more in the details in our coming slides. Okay, SQL versus NoSQL is as an example, or as a comparison, in the structured database, you have those tables, and non-structured, you have tables, or I'm sorry, in this, in the structured database, you have the rows, they call them items there. You have the columns there, they call them attributes. Primary keys are there in both the areas, and then indexing is there. The structured databases, there are views, but over there in the non-structured, you will see secondary indexes or global indexes there, and nested tables, arrays, and lists, and all that. Example of a structured database is in Oracle is one example, and then you have MySQL, you have PostgreSQL. These are example of structured databases. And on the non-structured side, or the NoSQL side, DynamoDB is one example, which is very common these days, being utilized by a majority of the organizations out there. There are, although there are more, but 4 of them are very common one which Amazon offers. And it's not just only Amazon which offers, but all the cloud providers, they offers the similar type of databases. The first one is called Amazon RDS. RDS stands for Relational Database Service. Okay, in the Relational Database Service, Amazon has various SQL database engines. Also, Amazon has its own database engine as well, but it offers as well the MySQL, which is an open source database. Although Oracle bought that a couple of years back, but there's an open source type, which is also available for you guys, to work on. And then Postgres is another example of the structured database. Um, Microsoft SQL Server is also offered, inside the uh, Amazon database services. Then there is a Dynamo database or the NoSQL database. Amazon's NoSQL offering is called Dynamo database. There are several other types as well out there in the market. In that database, if you guys remember when we did the policies, we saw those. Can you mute yourself if you're not talking, please? Um, or maybe I'll mute someone here. Okay. All right. So the NoSQL side, mostly the values are stored in a key value pair. And key value pair, if you remember, when we saw the policies in the IAM section, but there was one key and there was a value associated with that. And also there was another very common example of key value pair is when we do the tagging inside the EC2 instances or S3 or whatever, whenever you go and do the tag. So tag also works on pretty much the similar principle that there is a key and there is a value associated with that. Remember, the key which we were normally or commonly using was the key name was name, and then the value was whatever the value we were providing to it, like it's a Linux instance or Windows instance or whatever. Okay, so normally those databases, the NoSQL ones, they work on that key value pair model. And then there is a data warehousing capability, which is Amazon calls it Redshift. And then there is a in-memory database. Amazon calls it Elasticache. About 5 or 8 years ago, Oracle came up with on-prem in-memory database. And at that time, in-memory databases, they were picking up pace. So your entire database schema and everything that runs in the memory, like in the RAM of the system. So those machines, they are very heavy on the memory side, like, several terabytes of memory. So just because of the faster nature of the memory, so your entire database resides in the memory. So the fetching time cuts down to microseconds, and your database is, it goes real fast. So Elasticache is a similar deployment by Amazon, which is the in-memory, like, things are running inside the memory, not on the disk. So disk is the slowest part in the storage ecosystem. And then, the fastest one is your RAM. And RAM is the expensive one, disk is the cheaper one. So normally that's why, previously your application or databases, they were running on the disk. But now, because of the advancement of the technology, the and also memory, they were coming, start coming in cheap. So that's why they came up with this idea to run it onto the inside the memory. These are some of the use cases, but that's not the final word of God. There will be more and more examples out there, but a couple of examples are like for the relational databases. They are they normally use for your traditional applications, or if you have any enterprise resource planning or customer relationship management or any e-commerce site running. So that's where, relational databases, they come in handy, and, normally they are, in use. Some examples, what Amazon offers, in this relational area. Amazon offers Aurora, and then, RDS, and, Redshift. Aurora is Amazon's own database. And it's a funny story. I would suggest you guys to do some research on it, how Amazon came up with their own database. Just to give you a quick hint. At one point in time in the past, Amazon and Oracle, they were running two companies, but they were running like friends. And then all of a sudden, Oracle's CEO, he decided to, get on a, some rift, with the Amazon people. And then they start charging, heavily, and some, crazy amount. Yeah, exactly, Larry Ellison. And so Uncle Larry went on a, on a different type of rant with, with Jeff Bezos. So at that time, and then they started charging like crazy with the, with their customers running Oracle database in the Amazon cloud. And at that time, Amazon decided to, go for their own database. And then, that's how, this whole thing started, and Amazon came up with their own database. The second database type, you see that, a key value pair, which is, the NoSQL type, mainly for high traffic web apps, or, or gaming application, or whatever, or whatnot. Currently I'm seeing, startups, or, companies that work, mainly on, the app side, or for the ease of use, they use this, the NoSQL or the Amazon Dynamo DB. In memory is mainly for, caching services, or, geospatial, or the leaderboards type use cases. Elasticache and Memcache, and, Redis is there for you. For the document database types, let's say you have the content management, or cataloging. They have the Amazon, document DB that has the MongoDB capability. Then white column, and then, graph databases, time series, and ledgers. Those who are interested in, in fraud detection, or databases that require an extensive amount of relationship among the elements, or among the items. Graph databases are, very common in use. A couple of years back, there was, what's that called? Panama Papers, or Panama Leaks came out, and the people who started working on it, because the amount was, the amount of, or the size of the data that they were getting from those, Panama Papers, it was enormous. And for them to, if they put it into the regular database, it would take them, several years to just, come up to some sort of, conclusion on that. So they decided to use graph database. So graph databases, just as an example, if you've seen, fraud detection in movies, where, the detective has, a whiteboard there, and he has, a suspect there, and then, some push pins on the board, and then, some threads going, from one push pin to another push pin. And you see, that entire, graph connecting, different points there. So it is based on the similar principle. Very common use case in the fraud detection, no matter what type. It could be a financial fraud detection, or it could be no matter what, let's say, what do you call it? Very common use case these days is, insurance fraud, and, of that sort. So, these graph databases, they are, normally used in that area. And then time series, and then, ledger. So let's say you have you're working on the accounting side or on the ledgers, they have the Amazon QLDB. So they are normally called the hyper ledgers. Pretty much, around the similar principle of, what the Bitcoin is set up there. So if you are, in that arena, or if you are interested in this, you might want to, play into that, into the Amazon QLDB side. This slide it talks about it. It has two different areas here. So on the relational database area on the left hand side of the slide, you see Amazon offers RDS, and under the RDS, it's Amazon's own Aurora, and then it has MySQL, which is the open source, and then Postgres, which is also open source. And on the commercial side, yes, Amazon offers Oracle and also Microsoft SQL Server. And then on the community area or the community side or the open source, similar thing, plus MariaDB as well. These are the relational ones, and along with that, inside the relational one, Amazon also offers data warehouse capability as well, and they call it Amazon Redshift. On the right hand side of the slide, you're seeing a non-relational databases. Dynamo DB is one example, which is their NoSQL, and then Elasticache, and then their Graph database. They have document database, Redis, Memcache, and all that. At the bottom, you're seeing Amazon Database Migration Service. Amazon recently started offering that, maybe a year or 2 years ago. But still, I mean, there are several other types of migration services, like third-party tools out there that help you migrate your database from one database type to the another database type into the cloud or whatever and whatnot.
Faisal, very quick question came. Give some examples of the non-relational databases for an e-commerce side. What are some of the use cases of the non-relational side for e-commerce?
Okay. Do you have anything in your mind, Kamal bhai?
So yeah, I mean, so from an e-commerce side, if you look at the transient nature of some of the data, right? The e-commerce pipeline, there are merchant accounts. So merchant accounts processes don't necessarily have to have the customer information. They don't need to maintain the product information. What they have is, hey, for this transaction, here's the authorization number, here's the amount, and who the merchant account is. So that use case for those e-commerce pipeline, I'm just using one of the examples here. For those services, you don't necessarily need to have the bulky relational database management system. Those vendors, those service providers can leverage the non-relational database management systems to basically stand up their services. So integration services these days is a prime candidate for non-relational databases.
When you say integration, what does that mean? If you can elaborate a bit.
So let's take PayPal, right? Or Zelle. They are basically facilitating party A to transact with party B.
Gotcha.
They don't need any other overhead. So that's an integration service.
Okay, thank you.
Thank you, Faisal.
Yeah, sure. All right. So Hassan, you're right. Yes, Oracle making mistakes. I'm being recorded right now. Maybe after the recording, I have quite a lot of stories with that.
That is recorded, by the way.
I'm sorry, what?
This statement was recorded.
Yes. I started my career with Oracle. I worked for Oracle about some 8 years. So yeah, I have a very first-hand experience on similar things. Back then, cloud was not there, but yeah, there were quite a lot of things. So yeah. Alrighty, so let's move on. Okay, similar thing, more examples and how Amazon is glorifying it, that what performance gain or what monetary gain or whatever type of gain you're gonna get if you go with the databases running on the AWS, right? So they have under the Aurora window, or sorry, Aurora umbrella, their Postgres or MySQL compatible databases, they are about the 10th of a cost. If you do it on-prem or with any other provider. Manage cloud services, or sorry, manage database services with just a few clicks, and that is correct. And we're gonna see it. We're gonna witness this. Once we're gonna go do the lab. Serverless NoSQL, this they offer that. Data warehouse service, same thing, 10th the cost. And then several other glorifying things, they talk about their database offerings. And then application type, as Kumalbhai mentioned about one of the area on the integration services for the for our Dynamo DB or the that database type. So that's there are couple more examples here. Hospitality or the ride sharing, where store the structure or unstructured data, or where you don't have to worry about that extensive structured nature of the database. That's where you go and you utilize that NoSQL capability. Okay, coming to the next one, and this is about the some free learning areas here. If you guys recall, we talked about it in one of the initial classes. Let's say you have an extensive background in the database area, in the on-prem side, or you've been a DBA, maybe you are currently a DBA, or you have been a DBA, previously in previous years. Now is the time for you to get into the cloud databases. So you don't have to worry about, majority of the things. Previously, we used to have a dedicated DBA, or if it's a bigger company, dedicated team of DBAs. They were performing, that DBA work. But now, how the things have been rolled into, so along with the cloud administration or cloud engineering work, you must be knowing how the databases are set up, how the tuning is done, or how the databases are being backed up, or how to export and import, or how to restore from the previous backup and all that. So all these things, they are on the console available for you, or if you are comfortable with the command line, you can perform pretty much entire thing end to end through the command line. So if you have interest in the back end or into the database side, get yourself into it. Or you want to get yourself into a niche. Hey, you know what? I want to just specifically focus on, let's say, on the document side, or specifically focus on the graph database, or on the data warehouse side, or on the NoSQL side, or whatever, right? So pick that niche, run with it. Like Kamalbhai just mentioned about the integration services. Pick that niche, go run with it. Okay, or pick the graph database, go run with it. Say there are several different types in here, or whichever you feel that you are you're gonna be comfortable with it. Pick that area and then run with it. So this actually concludes our database part. I'm gonna pause it here for any questions that you guys have before I move on to the next topic, which is kind of a huge topic here for us today.
This is Ali. Assalamu alaikum. So I have a question. So what it feels like to me, rather than if I was on a cloud and putting in a Windows server, installing SQL on it, I can just get get SQL services from Amazon, whether that's SQL database or whatever I need, and just put the data on there without requiring the Windows platform. Is that what I'm getting from this whole topic today?
You can do that as well. Yeah, and exactly. And so one thing is, why take the pain of building the server, configuring that, and then configuring installing and then configuring the database on it, and then be responsible for for the end-to-end part of it, right? Why not just simply go into the console, create the database, you got the access, and you're done with it. So it is so Amazon is giving you that capability to not to worry about the underlying infrastructure, but just pick it up from there and go run with that. But if, let's say, your organization wants it to be, hey, you know what, let's build the infrastructure, let's install and then configure the database. Yes, that capability is there as well.
Okay. And if we were to go with Amazon database, can we still do reports and create reports and connect with the ODBC connection into that database?
Everything.
Okay.
So yeah. So
if I may add.
Yes, yeah. Go ahead, Mike. Go ahead.
Brother Ali, this RDS can be assumed as a demise for the traditional DBAs. Okay, no offense to any DBAs. I was a former DBA myself. As Faisal Bhai mentioned, as a DBA, database administrator, you would set up the server, install the software, configure the software, configure the backups, maintain the high availability, and apart from all of that, do the data administration and whatnot.
Correct.
Right?
Mm-hmm.
All of those things have been streamlined. If you want high availability, it comes right out of the box. If you wanted to set up the server, just a point click, bingo, the entire setup is available. If the database goes down in one AZ, there is a multi-AZ configuration. Just click that. The database is available in a high availability mode right off the bat. Okay. So, and backup, recovery and all those things are available right out of the box.
Like how we do in servers, you do the database clustering. Is that also allowed? Because usually, if to do SQL clustering, to have a SQL cluster and have database, in that way, you need a double take software or something like that. So, is
why
that
do you do clustering for high availability?
Right.
It's available right out of the box.
Okay.
It's just a click. It's just a click in the console.
Exactly.
Okay. Thank you.
Yeah, when Ali, when we're gonna do the lab, you're gonna be surprised to see the thing that used to take days is just click, click, click in a couple of minutes, and you are done with that. You have the entire capability available there for you.
Oh, by the way, they also do the minor upgrades themselves.
Yes.
You don't even have to worry about it.
Okay, and I'm assuming that they upgrade the SQL like from 2016 to 2019. You have to do like a whole lift off and whatnot. Amazon is responsible for upgrading the backend SQL infrastructure, whatever the latest version is.
Yeah. So once you set up the service, they will start notifying you whenever they're planning. So they'll coordinate with you but all of that work is done as part of their managed service.
And is that a service you have to buy, or is that what you get when you create a SQL or a database instance?
Yep, you get it as part of that service. That's it.
Okay.
So you define the maintenance window. Either you let Amazon pick the maintenance window, or you define, let's say, that do not perform any maintenance work during my business hours.
Yep.
Or certain window, you define it to them in the console when you set up the database, and we'll show you everything on that. But yeah, just to answer your question, yes, it's all there. You click, you define your window and all that, and you're done with it.
And the programmers, like my programmers, they can connect using the ODBC to create dashboards, chart, whatever they need to do.
Everything.
From an application standpoint, they all have access to a database just like they would on a traditional basis. Yes.
Awesome. Thank you.
Yeah. So yeah, Ali, you or anyone else who is in the currently working as a DBA or or in the database area, it's very simple now. Things that used to be, days work, even your minor tasks, now is just, majority of them, they are either click away or Amazon is, handling it for you. Now I was actually, trying to get into the console. Previously, what Amazon used to tell you is, let's say if you launch an instance, I am in the console right now. If you launch an instance, here, choosing the AMI, they recently changed it. Like this piece here in the, this blue box here, they used to have that. This is currently, they are glorifying to go with the, their Lambda services, instead of, doing the running the entire setting up the entire infrastructure. Just put the code there and you're done with that. So in this blue window, they used to have about the their RDS service. Then instead of setting up the Linux or Windows server, use their RDS service, and that actually takes you to their RDS dashboard and get the work done. Anyways, okay. Anyone else? Any question? Okay, alrighty. So before I start, do you guys want to take a break now, or want me to just continue for next hour and a half? Because this is a very detailed and extensive topic, which we're going to cover from now, this networking services. Okay. All right. So we'll take a 5 minutes break. We're gonna continue back on at 6:55. To answer Murtaza's question, yes, Murtaza, Amazon offers that service. Plus, there are several third-party services, that offer the similar thing. You don't have to purchase or get Amazon service. Services out there, they also, or companies out there, they also offer this similar service.
Faisal bhai,
Yes, sir.
are you open for some casual discussion?
Yeah, sure.
Okay. So one of the brothers was asking, what are some of the options to basically take this knowledge and apply it as a professional work, and so that they can add it on their resume as an experience.
So this thing which we are teaching them?
Yeah, not just this, but also the application development and other areas.
Yeah.
So how can we get this knowledge added as an work experience?
Work experience.
So, Brother Ali Akbar, are you still here?
Yes, Kamal.
Did I phrase your question correctly?
Yes. I mean, is there any way where we could, rather than going out and doing some freelancing project that might be difficult, if there's any project that's going on where we could participate and work, get some hands-on experience that could be utilized, and honestly, doing in a professional setting, it's different versus doing it by yourself.
So one thing I could think of is, actually two things just popped up to my mind. One is, with Kumail Bhai's work, you're creating end-to-end application, you're going to put it to your GitLab, and then you can put it into your resume. Hey, you know what? I built this. This is my Git repository. Go check that, right? Also, I can show you, let's say, AWS complex. I'm just right. So what I did, I search is AWS complex application examples. I'm going to go into the images here. or you can go all here and there are 10 practical examples of Amazon AWS Lambda services or serverless application. You can go into the images based on our today's and tomorrow's lab. Let me just pick it up here. If you see this, you can easily create, let's say you pick this one up, you came up with an application name. Hey, you know what? I created this, let's say Munazaf. Okay. So instead of Munazaf on your, for those of us who are not in Kumail Bhai's class, Munazaf is the name of the application he's building end to end. It's an e-commerce platform he's building. So he started off with basic HTML, CSS, and then they switched to Node.js Express framework, and the backend database is MySQL. Everything is running to localhost or to their local machines. And you guys can take that project, put it into the cloud. Okay. You can start off with, hey, you know what? I'm going to set up the AWS boundary here with the VPC. And then inside the VPC, I'm going to set up a 3-tier architecture. I'm going to set up my web server. I'm going to set up my app server. And then I'm going to set up my database server. And then based on that, and you can use pretty much all those free services. And, you know, based on that. Sorry, was that a question? Okay. So
yeah,
you can,
I'm sorry, David.
Yeah. So you can pick it all up. You don't have to, pick this whole thing, but, set it up accordingly. And then, you get the connectivity through the CloudFront to the S3 bucket. If we did the S3, and we're going to be doing this net gateway, public subnet, app subnet, or data subnet. And, based on that, you set it all up. You put it into your resume. Hey, you know what? This is what I set up in your Git repository. You can put this diagram. Hey, you know what? I created this end to end, and then you can take that point forward. And based on that, also you put the HA capability there. You're gonna put the auto scaling capability there. And you will learn, this whole thing of, all these, network related things, in coming days, today and tomorrow, actually. So yes, go search for that project, pick it up, and then see how you can either mimic this into your AWS account, or how you can elaborate on that or expand on it. Or maybe you're talking to some friend, hey, you know what? I am trying to build this application, but I don't know where to start from. So you can offer your services. Hey, you know what? I can help you build the infrastructure, or I can help you build, the architecture and all that, the network services or VPC and all that, and the security around it. And then, we can take it forward. Or you can create a POC for them to show them, hey, you know what? This is how it's going to look like on right now. It's a 1/10 of that bigger scale that you're seeing. And if you want, we can just take it to the next level. So the options are endless here.
Yeah, true.
So one, just to add to that, Brother Egbert, deploying this application, whatever application that you are capable of building, deploying it on the internet, making it available, that's that's something that you can showcase. That's more valuable than just adding a lot of extra description on the resume. Say, hey, this is my website. Go here. I've developed it from scratch. It's running on AWS. That gives the potential employer a confidence. Hey, this person not only knows the platform, but also understands the application development. Gives a that full stack developer confidence, essentially.
True. Yeah, but also working in a professional setting, right? I mean, I know this is like the whole end-to-end thing. There are many. I know you within like 10 sessions or 20 sessions doing this whole thing, you guys have done a miracle. I don't know. I've learned databases, so I know it's like what you taught in like 30 minutes. It was a whole class for us in the semester. So way back. I'm talking about like 15 years back. But I get that it's difficult. So I mean, but then you take that in a professional setting, and you end up learning a bit more here and there. I was looking at more from that perspective and that aspect too. Definitely, this is a good start. You can take this and go and build. Let's say, I mean, if you have to start building an application architecture, how do you do that, right? So that comes out of experience. Definitely, you cannot teach in a class. You go in your hands and you learn that. But then that's where it's okay, if you're working with someone.
But by the way, I'll just give you my personal opinion, and no offense to anybody, especially Faisal Bhai. Please, ignore my comment. I don't think there is a perfect architect or architecture.
Yep.
It's always a trial and run.
Yep. I totally agree. Yes.
True. I mean, but then you need to at least you know how the pieces fit in the puzzle, right? If you know about the pieces, then you can add them into the puzzle. But here, if you don't know the pieces themselves, it's really difficult to add them, and you create chaos.
And this class is making you aware of, Faisal Bhai is making you aware of those puzzles.
Oh yes. This is really helpful. I mean, for me, it was like many a times it was just going out, Googling everything and reading and understanding. It's like, oh, this is what it does, and okay, Kafka is this, and that is that, and this is this. And I'm like, okay, where do you stop?
By the way, you don't need to worry about Kafka anymore. There is a streaming service that's available. Just point and click.
And again, it depends on what you're what's your use case, right?
Whatever you could do with Kafka, you could do with Kinesis.
True. Very true.
One more thing. You don't have to reinvent the wheel. Let's say you find something at your work. You pick it up, optimize on it, provide the solution or provide the blueprint to your boss, or maybe to the other group. Hey, you know what? This is what I'm seeing that you guys are doing a conventional way. This is my idea, and this will save you this much amount of money, this much amount of time, and start off with that, or the application that you're building at Kumail Bhai's Kumail Bhai's class. It's not just a project that you're doing just for the heck of it. Maybe take that project to a next level. Open your.
I'm actually doing that, Faisal. I'm actually doing that. I'm just building something as a start and then taking it to the next level. And okay, we'll probably. That's where I was looking at, like, to collaborate with somebody to to take it to a different thing altogether. But sure, let's see how that works out, inshallah.
Okay, perfect. I'm gonna take a quick 2-minute break, and I'll be back shortly. Okay. Kumail bhai, can you hold the fort for me, please?
Jazakallah, thank you very much for your answers.
Yes, sure. And for those who are interested in learning about the Node class, just send an email to Faisal Bhai. You know what? Let me just share my email address here. I'll provide you the video links once we are done. Okay. Our classes are in session. We're almost done next week, but I'll be able to provide you the video links if you're interested. I'll share.
Okay, guys, this is Mujahid. Now that Faisal is not here, I can take the liberty of saying what I'm saying. Did you all get the hint? He used to be an Oracle DBA.
I used to be an Oracle DBA myself too.
Yes, but that's the message for all of us students. Keep your eyes open for what's the new thing, learn and move on. That's what he keeps saying. Get your niche and move and stay in a niche if you want a stable living. When everybody jumps into it, it's too late. So that was my 2 cents. Thank you.
And Murtaza, earlier you mentioned about the possibility of using hackathons. Yeah, that's definitely a possibility. Last year, we, as part of this training regiment, we introduced the concept. This is for everyone to actually develop a 5 different products. So I think Faisalbhai mentioned in the earlier sessions, there was the venture capitalist leaders from our community looked at some of the products. We did the rating and selected on few products to develop, and we were locked in at the at the Hosseini Mambarga for the weekends to actually do the development. Uh, that the products were developed, uh, and more importantly, is some of those individuals who participate in that program, they were able to add that experience in on their resume. And Alhamdulillah, at least I know 2 individuals who were able to change their career and landed in an IT jobs as part of that effort. So Alhamdulillah.
MashaAllah. Thank you so much, Kamal Bhai, for sharing that.
Yeah.
I mean, we don't get to see the results as much as we get to see all of that. I don't think we're gonna have a next hackathon. It might be a hard ask.
Yeah, Mubashir is one of them. He was part of your team, Murtaza.
MashaAllah.
Yeah.
Thank you.
Alrighty, I'm back, guys. Okay, so let's get started. And this topic will be a bit complicated or a bit over the top for you guys, of those who have not experienced the uh, the networking portion, be it on-prem or be it on the cloud side. So that's why I'm gonna start off from the scratch. What is networking? What is subnetting? How does it work? And we'll try to cover this in next hour 15, this entire thing. And feel free to stop me, and feel free to you know uh, uh, ask questions here, please. I know that this was always been a challenge for me to deliver this networking section in one session, for those people who have no idea how IP addressing works and what IP addressing is, by the way. Okay, so quite a lot of things we're going to be covering here today. All right, so there are 2 major types of IP addressing currently available in the industry. I want you guys to do some research for me, come up with an answer by tomorrow or by the next week's class. So right now we have IP version 4 and IP version 6 currently been deployed as an industry standard these days. So no matter what type of network device it is, no matter which layer does it work on, how it gets connected with the other appliance or other device, IP version 4 or IPv4 and the IPv6 are the ones which are very commonly used these days in the industry. Question for you guys is, what was the purpose of IP version 1, version 2, and version 3? Why are they not currently in use? And also, why there was a jump from IPv4 to IPv6? Where did IPv5 go? Okay, so this is the question for you guys to do some research, and we'll have a conversation hopefully either tomorrow or the following week. how the IP addressing works. Let me see if I have that. 1 second. So how IP addressing works is we have about 32 bits in the address field. Like the total is a 32-bit, or if you merge them all together, it's a 4-byte size packet, the IPv4 packet. And then IPv6 is more than double the size of that. Okay, IPv6 is 128-bit in size, and or if you put it this way, it's a 16-byte total packet size. Number of addresses what IPv4 offers is over 4.2 million, like over 4.2 million IP addresses we can get out of this IPv4 entire range, from class A to class E. IPv6 is, I don't know, some more than some trillion. It's 2 to the power of 128. So if you do the math, the numbers, even if you just keep counting the commas, it's quite a lot. How the addressing format works: IPv4 is a dotted notation. So there are 3 dots, and each dot separates each octet. So there are 4 octets, 1, 2, 3, 4, and they are separated by dots. So you must have seen IP address like 10.0.0.1, or let's say 192.168.1.1 or something like that. So that is a dotted notation, that these IP addresses are separated by dots. Each octet has its own significance based on their classes, and then based on the classes, the dot separation plus which portion is for the network and which portion is for the number of hosts. That's what it defines inside the IPv4. IPv6, they are separated by colons, and there are 8 fields. Like in version 4, there were 4 fields. In version 6, there are 8 fields. Quite a big of a bucket we have for IP6, quite a smaller bucket we had for IP4. Why we shifted from 4 to 6? At one point in time, there was a thought came in that if we just keep applying those IP addresses to all those devices, at one point in time, we're going to deplete those IP addresses, and we're going to run out of those IP addresses. So to address that, they came up with 4 times the size of the V4. They came up with IP6, and one of the reasons behind that, because how the technology is advancing, like because of this IoT and plus like minor devices or minor things, even within your house, they have an IP address. Like there are now network connected bulbs or lamps that they have introduced. Like you can get them from Amazon or even from Walmart. Assign an IP address to it, and you can control it with your phone. So with the advent of IoT, all those small devices, they are assigned with an IP address. So if we assign those IP4 addresses to them, we're going to deplete them real fast. So that's why they came up with this IP6, which is like 4 times the capacity, and that will address this anticipated or projected growth. I can give you an example. If I click on this window key and then type CMD, it will open a black window here on my screen. If I just simply type the command ipconfig, okay, and hit enter here, you see that I have an IP address assigned to my wireless adapter. My IP address is assigned to me through my router. Okay. And that router has assigned this IP address to me. And this IP address was assigned because there is a pool of IP addresses provided within my router. Even if you go check your router, you will have that pool defined there. That pool is called DHCP. DHCP stands for Dynamic Host Config Protocol. So what happens is there is a pool. Let's say my router has a defined pool of, let's say, 192.168.137.1 through, let's say, 100. So those 101 IP addresses are set aside there. So soon as a device powers up, let's say my laptop powers up, it goes in and, gets the IP address, from my router. And, the router actually assigns that IP to my machine. So however many devices I have in my house, they all go and, connect to that and, get the IP address, from there. Also, the router also has a capability to assign the IP6 addresses. I'm not going to go further details on IP6. I want you guys to focus on IP4 for now. And, just focus on it and, understand IP4 end to end, and then, work on IP6. Okay. Principle is pretty much the same. It's just that the size is bigger, the bucket is bigger, and, it covers, a lot of, bigger things there. Okay. So this is how I get the IP address. So for Windows users, you type the command ipconfig. For Linux users, or in your Linux instances, the command is ifconfig. Instead of IP, the command is ifconfig or ifconfig. It is the interface config. That's what they call it. And I believe the Mac users also would have the same, like you go into your terminal and run the command ifconfig, and you should, get the information there. Anyways, so this IP4 is the one which is assigned to my laptop. Also, IP6 is also assigned to my laptop. But IP4 is the one, which I am, focusing on. So what I'm seeing here is, this is my IP address. This is the subnet mask, and this is the default gateway. So in every block of IP addresses, there are a couple of things which we need to consider. One is, what is the size of the block? How many IP addresses are in that block? The block could be a bigger one, block could be a smaller one, depending on my requirement. And also in that block, what is the default gateway? The default gateway is, that's where the packet are gonna go to the first hop. So in my case, in my home network, if I just go in there, 1 second. So let's say this is my router, my home router that is connected to the internet. And there are a couple of machines that are connected. Let's say this is my laptop, this is my dad's laptop, my kid's laptop, or, my kid's gaming system, and my, let's say my phone, my wife's phone, and, whatever and whatnot, right? So they all are, all the devices, they are connecting to the router. So soon as these devices connect to the router, so what router does is, it goes there, and then router assigns an IP to it. So I have the IP, and then I have the default gateway there. Okay, don't worry about the other pieces. Okay, so IP is assigned there, and the default gateway, which is assigned, the default gateway is normally the IP address of the first hop. The first hop for all these devices is the router. So the default gateway is the IP address of my router here. Okay, let's just call it DG or default gateway. So default gateway is, in my case, the first hop is the router. Let's say I have, let's say, a firewall in between. So my first hop will be that firewall, and then the next hop will be the router. So whatever the first hop is, either if that device is working as a gateway, so we'll get that IP address assigned to that. Now what happened is, let's say if this is a IP pool, let's say starting from 10.0.0.1, and it goes up to 10.0.0.254, starting from 1 through 254. So I have 255 IP addresses in that range, out of which normally the last one and the first one, they are reserved. The first one is the network IP, and the last one is the broadcast IP. I know I'm taking a lot of new lingos for you guys. Just stay with me for a while, okay? So the first one is the first IP address is set aside for the network, and the last IP is set aside for the broadcast. Now, some organizations, what they do is they pick the second last one for the gateway, or some organizations, they pick the second IP address as the gateway. It depends on the organization. Either they pick the top one or they pick the last one, like the second last one or the second from the top. Okay, so that gateway is the one which is this IP is assigned to that gateway device. Okay, that's where the traffic is going to flow through, or that will be the device that all the traffic will be going or hitting the first, or they call it the first hop, okay, or the first jump. Okay, now in every subnet we have to set aside 2 IP addresses. The very top one or very last one, we are not supposed to use it. We cannot use it. So let's say I have carved out a subnet. Subnet is like you have a block of ice, you carved out something out of it. So once you carve out the block of ice, there is some residual amount that actually gets wasted. So the wasted one, although for the lack of better term here, in this case, the wasted one is the first 2, actually the 2 from it, right? So one is the network portion, and the last one, which is the broadcast portion. Okay, so this is the standard for any subnet carving out. That's where you lose 2 IP addresses. So let's say I have this big block of IP addresses, however many carves or blocks I'm going to carve out of it. So every time I slice it through, or every time I run the knife, I'm going to be losing at least 2 IP addresses. Okay, so I'm going to lose 1 IP here, 1 IP here, 1 here, and 1 here. See, same goes here, same goes here. But let's say if this one is a bigger block, so I'm gonna lose 1 from the top and 1 from the bottom. Okay, so whenever you go create a subnet, do your due diligence. Okay, it's mostly the network architect who does that work. Let's say you're working with the architect, and you're seeing that, and you're gonna ask a question, hey, how you're gonna slice it, or how you're gonna carve it out. So based on the requirement, you do not just simply create that based on your current requirement, but you look into the bigger picture. Hey, what is the capacity? What will be our growth, let's say in 1 year, 3 year, or 5 year, right? So based on that growth, you keep a room for that accommodated growth there. So let's say I carve out a smaller piece here. Let's say that gives me, let's say that gives me, for example, only 4 IP addresses here, 4 usable IP addresses here. And then the very next month we outgrown it and we needed, let's say, 2 more IPs. So what are we gonna do? Either we move the entire infrastructure from here to, let's say, to this bigger one, re-IP them, and then, accommodate them here. Or the best practice is carve out, let's say, a bigger one here. Let's say it gives me, for example, 24 IP addresses. I am currently using 4 here, but it has an accommodated growth for my future capacity as well. Okay, so based on the requirement, you carve it out accordingly. If I go back here, okay, so if I go into this dotted notation, IP addresses, they work on a similar binary principle. Either the value is 0 or value is 1. Okay, if I go in here, all right, okay, so if I go in here, where is my, okay. So these are the 4 octets I created. Okay, and if you recall, my IP address was, let's say my IP address is here. If I copied here, and if I just paste in here, what is my IP address? My IP address is 192.168.1.156. Okay, so 192 is my first octet. Second octet is 168. Third octet is 1, and the fourth octet value is 156. Okay, so each dot is separating out each octet here. Okay, now actually it's not 1 through 8, it's 1 through 8 in a reverse order. Okay, 1 2 3 6 7 8. Okay, this is the rightmost bit and this is the leftmost bit. Okay, and similar principle goes to, all right, these octets as well. Okay, 156 is going to take me a bit to calculate that for you. So for number 1 is, it will be, the first bit will be 1, the rest of them will be 0 if I convert that into binary. Similar goes, with 168, it will be, I don't remember what is that. We can quickly do that, but anyways, so just to give you an understanding. So IP addresses, what number we are seeing, they get converted into the binary, and then, based on that binary, that's how the packet, flows through, from one device to another device. This is a size, so this whole thing here, this is a size of 1 IP packet or 1 IP address here. Let's not go into the packets for now. Okay, now what is happening here is, if I go in here and if I take you guys back there to IPv4s, there are 5 different classes in IPv4. So going forward, everything that you are going to hear from me, that is all related to IPv4. So I'm going to call it IP. Okay, unless there comes something about with the IPv6, then I'll call it IPv6. Otherwise, if I say IP, that means IPv4. Okay, so on the right hand side here of the screen, you're seeing 5 different classes. Okay, IP addresses are separated out into 5 different classes. Class A, Class B, C, D, and E. Okay. Don't worry about the bottom 2, Class D and E. Don't worry about it. Okay. Just worry about the first 3 classes, Class A, B, and C. Okay. This is a very common question in the interview. How many classes are there? What is their classification? Or if, let's say if you're working on the network side, you should be knowing, all this. Okay. So in Class A, the IP addressing starts from 1 and it goes up to 126. Actually, it goes up to 127. So 1 through 127 is the Class A. Okay. What is that 1 through 127? That is the first octet. Okay. Here you see the first octet. So Class A is, if I just unhide this, come on. Come on, what is happening? So the first octet, okay, Class A is 1 through 127. Okay, right now you're seeing this value 192. This is the first octet value. So Class A has 1 through 127. Okay, Class B starts from 128 through 191. Okay, 128 through 191. Okay, this is the first octet value. And then Class C starts from 192 and it goes up to 254. Oh, sorry, 223. 223. Okay, don't worry about Class D and E. Okay, at this time. Let me just quickly do this here. Okay, so don't worry about Class D and E. So let's say if I have an IP address, for example, I have an IP address 10.1.2.99. This falls under Class A because the first octet is 10 and 10 falls under 10 falls between 1 and 127. Or let's say I have an IP address of 124.234.38.10. Let's say if I have this IP address, I'm just making it up. So this also falls under this Class A. Similar goes with Class B. Let's say if I have an IP address, for example, let's say 130.38.78.240. That IP address actually falls under Class B. And then, similar goes with Class C, that it falls under Class C. So if you see that my machine IP address, my laptop current IP address is this 192.168.1.156, this falls under Class C. It falls under the Class C category of our IPv4. Okay. So this actually defines our classes. There are 5 classes, 3 of importance for you. Don't worry about the bottom 2 classes. Okay. All right. So if I go back here, in every IP address, there are 2 major portions. One portion, left portion on the IP addressing is called the network ID. And then the right portion is called the host ID. Okay. In Class A, the network portion is smaller, but the host portion is bigger. Okay. You see that the Class A, so wherever it says byte 1, byte 2, byte 3, byte 4, so read this as octet 1, octet 2, octet 3, octet 4. Okay. Like these octets 1, 2, 3, and 4. Okay. So if the network resides within the first octet, and then the rest of the octets are, excuse me, rest of the octets are set aside for the host, that is a class A. For class B, the network resides on the first 2 octets, and then the remaining 2 octets are for the host. Class C is a reverse of class A. That is 3 octets are for class, 3 octets are for the network ID, and 4th octet is for the host. Okay. What is network and what is host? Okay. So host is any machine like my laptop, my phone, my kid's laptop, my dad's laptop, and all those. These are individual hosts. In our AWS example, let's say we have 5 Linux instances, so they are 5 different hosts. 2 Windows instances, so a total of 7 different hosts we have. An S3 bucket that has an IP assigned to it, that is 1 more host. So each component that has an IP address assigned to it, that is called host. So the host is actually the number of machines that we can connect using that IP address or IP subnet or IP scheme. So let's say if we have a class A network, that means we have a larger number of hosts to assign the IP addresses to. Class B, lesser number than class A, okay, because it has 1 less octet. And class C has a larger, has a smaller number of host component there, okay. Don't worry about the subnet mask. I don't want to go into details and make you guys or complicate things more for you guys, okay. Let me come to this portion here, and then within those IP addresses, let's just go in there. You see that class A is 1 through 127. That range is for the class A. Then class B has a certain range, and then class C has a certain range. Within these certain ranges, there are 2 major demarcations. Those demarcations are either you call them routable versus non-routable IP addresses, or you call them public versus private IP addresses, okay? Or reserved versus unreserved IP addresses, okay? So each class A, class B, and class C, each class has a specific IP scheme or IP range that is set aside as a reserved IP address or as a non-routable IP address, okay? And what are those reserved IP addresses? Class A has a range of 10.0.0/8, and I'm going to come to it. What is that /8, 12, or 16 means, okay? So class A has this, wherever the IP range starts with 10 dot, it's a reserved one. Class B, starting with 172.16, is a reserved one, okay? Class C, 192.168 is a reserved one. Okay, what is the purpose of a reserved one? So what reserved IP addresses do is, let's say this is my router here. Anything reside behind that router, you see that I am getting IP address 192.168.1.3, 1.4, 1.1, 1.2, or remember, I have the IP address around the same range, 192.168.1.156. So all these IP addresses that are assigned behind my router, or my router assigned these IPs to these devices. Say this is my laptop, this is my dad's laptop, this is my kid's laptop, or my 4th machine here. So all these machines that are assigned an IP address, these IP address, they will not be published to the outside world. The outside world will not be able to hit them or will not be able to connect to them, because these are non-routable. Non-routable means that they stay within a certain domain. They do not go beyond that boundary. So if we assign a routable IP to, let's say, all these 4 machines, so it will be assigned out of this range, because this range 192.168 is a reserved range. So if I have to assign an IP, let's say I assign 191.168, that is not a reserved range, because this is the reserve 172 or 192. 191.168 is not a reserved range. So what's going to happen is outside world will be able to access it. So what's happening in my case and in every one of you out here, in your home networks, your router assigns you an IP either from this range or from this range or from this range. So what is the benefit we're going to get out of it? Because the IP addresses are assigned from one of these ranges, these IP addresses are assigned to all those devices behind the router. So they will not be published to the outside world. So the actual usable IP addresses, they will not get wasted. Let's say if I assign the usable IP addresses to all, let's say all these 5 devices in my network here, and none of this device is going to the outside world, that means that I have wasted these 5 IP addresses. So to preserve these IP addresses, from wasting, we assign the non-routable IP addresses behind the router. So these machines, they will just get connected to the router. And since my router has the internet connectivity, so my router gets an IP address. That's the public IP address. Okay. So coming back here, these reserved spaces, they are also called private IP addresses. Okay. Anything which is not assigned out of these ranges, that is called the public IP address. Public IP addresses are expensive. You have to pay for it. There are certain organizations that sell you, block of IP addresses, public IP addresses that you purchase for your organization for that specific purpose. And then, you pay certain charges for that, because, public IP addresses, they are hard commodity. So you do not assign those public IP addresses to your devices that do not go outside or that cannot be accessed from the outside. Okay. So in our case, in my case, or in your case as well, so this is my router, my home router. It is connected to the internet. Okay. And then I have several machines connected to it, my laptop, my phone, and other devices here. So all these devices here in this dotted line, they have 192.168 IP address. Okay. They are connected to this router. Okay. They all are connected to this router here. And then this router, you see that this router has 2 interfaces. Okay. One interface is this, and the second interface is this. Okay. This interface here, you see that I set it up as a default gateway. So the default gateway has this IP address, .254. So this local interface has 192.168.254. Okay. This is the IP address assigned to this local interface. So I must have an IP address assigned to the router here that should be a public or a non-routable IP address. Okay. How do I find that? One method is I log in to this IP address and find my IP. Or the second option is I can go to my browser. Let me just pull one browser window here. I can go to browser, and there are various services. If I just type what is my IP address, IP port address. Come on, man, show me the IP address. Showing me the IP4 earlier. Anyways, I could show you guys what is my public IPv4 address. Come on, man. How do I find my anyways, so if you just type what is my IP, and it gives you the IP address. What is my public IP address? Okay, what is my IP? Looks like my router is just showing my IP6 address here. But anyways, that IP would be like 38 dot whatever. So that IP, that public IP, which is assigned to this interface, it will be from the public range, not from the private range. If you see that, not from this private range, but from the public range. And as an example here, so all these devices that are connecting to my router. So router has two interfaces. One interface has assigned with this IP address because all these devices are connecting to it. And the other interface of my router, which is connected to the internet, that IP is whatever, right? It's just an example here. So this 109 dot whatever. So this is not from any of those ranges here. So that is a public IP. So I can access this IP from the outside world. Okay. Let me just quickly go to my console. If you guys remember, what we used to do is, I have two machines here. I am in the Ohio. I was just playing around with it for some reason. If I go to the instances here. This is my public Linux. Okay. Remember the public DNS, although it's blank here. I was playing around for some other reason. But see, this public IP is 3.17. This is what Amazon assigned to my Linux instance. And remember, we picked that public IP and then connect to it through our PuTTY session, since this is a Linux machine. Along with the public IP, our machine also has a private IP. You see our private range is 172.0, which 172 is the range. All this 172.16, but it is in the same range what I have for our reserve one. So all our Linux or Windows instances that we launch, it has two IP addresses. One is the public, one is the private. Okay, we connect to the public IP. We don't connect to the private IP. Okay, so whenever you launch now, you will see a private IP address also assigned to your instance as well. Okay, so this is the purpose of IP addresses, that you get your infrastructure connected, or your infrastructure connected to the router or whatever the device they are connecting to the to the next hop. And then since they are behind the internet, so you assign a private range to this blue block here, and assign it to your machines. Let's say you have a machine that requires a public IP, not a private IP, or maybe a public along with the private. Then you configure your router accordingly and assign the public IP to that. There are multiple ways of getting that work done. Okay. All right. So coming on next. Okay. There is another capability which is called NAT, or network address translation. So what's happening is our router, since these machines they are assigned with a private IP range. So what network address translation, or NAT, does is it translates. Let's say this machine wanted to go out to the internet, do some work, and then get back. So this machine, when it connects to the router translates its IP to its public IP, and then this public IP goes to the internet, gets whatever it needs to fetch. It comes back, then it translates back to its whatever the IP is, and then sends the packet to it. So there's a NAT table that is being maintained that machine A, which is internal, it goes to the outside world, so that the net or your router or your net machine or net device, it actually translates that, so that this machine is not exposed to the outside world. Okay. NAT is on a similar principle as proxy. I don't want to go into the detail and confuse you guys. So what happened is it goes out and then translates that. So whenever the packet comes in, so that packet gets validated against that table. Hey, you know what? This packet was mentioned or was destined for machine, let's say 1.4. It goes to the 1.4, and packet is delivered there. So that's the the main purpose of the NAT translation is. Now you were seeing that those slashes like /24 / whatever, right? So that slash notation is called the CIDR notation, or classless inter-domain routing. So either you remember it by the NAT mask, or you remember it by the slash. The more you work on the network side, you can do it in your sleep. /24 means that this many hosts. /12 means this many hosts. /30 means this many hosts. Okay, or this many usable IPs. Okay, so here /24 means, let me just go in there. Command spreadsheet, there it is. Okay, so each octet is 8, right? So how many octets are there? There are 4 octets, right? So 8, if I add this one here as well, 16, 24, 32. So its total is 32 bits here. If I go to my spreadsheet, here, remember 32 bits of the addressing. So how the 32 addressing works, 8 plus 8 plus 8 plus 8. Okay, so total is 32 bits. Okay, out of those 32 bits, class A takes care of the first bit. Okay, so you have 8-bit for the host. Okay, now the remaining 3, 8, 16, 24. So you have 24 bits available for the host section. Remember, 3 octets are set aside for host section. So that 24, how is it translated into? It is translated into 2 to the power of 24, 16 million, was that 16 million or whatever? I guess it is 16 million. So we have a usable 16 million hosts here. So I can assign 16 million IP addresses if I have a class A network. Okay. Class B, I have 2 bits set aside for the network, and then the remainder 2 are for the host. So remainder 2 will be 8 in one octet, 8 in another octet. So what would it be? 2 to the power of 8. I have 256 hosts available that I can utilize. And then here in the class C, I have, how many are these? These are 8. So it will be 2 to the power of 8, which is what is happening?
Yeah, specify you need to 16 then, right?
Sorry. All right, so 64K is class B. Sorry, thank you, Ashwak bhai. 64K is class B, and then 256 usable ones are in the class C. Okay, this is a conventional networking where you pick the subnet from that specific one and get the work done. Now, there is a terminology called subnetting. What subnetting does is, now that you know that we have a network part and then we have a host part. With the subnetting, we can play around with the network and the host part. Like we can borrow some bits from network to the host or vice versa. Like we can increase the size of the host part and decrease the size of the network part. Although we are still staying within the class A, but I can increase the size of the network part and decrease the size of the host part. You see here, I have the host part, and then host part is 1 octet, and then the network part is 1 octet, and then the host part is 3 octets. By using the subnetting, I can just turn this into this here. Like I can increase the network part and decrease the host part. Or I can do it vice versa, okay, in any of the class. So playing around with this area, like increasing one area, decreasing other, like, borrowing bits from here to there or there to here to increase one area or decrease one area, that part is called subnetting. You have the subnet, now you just, playing around with it to, work it around according to your needs or to your requirements. So in a conventional way, class A, how much is it? These are 8, right? So class A, in a conventional one, class A should have a subnet of /8. Okay. Class B is, how many are these? 8 plus 8. So this should have /16. And then class C is /24. Okay. But this is the conventional way of doing it. With the subnetting, we play around with it. Like, we can change from /8 to 9 /10 or /24 to 25, 26, and it goes up to /30. How do we do that? So our net mask changes, but our number of subnet actually, helps us out. So /24, sorry. /24 means this is /24. Is this the host part? Yeah. So host part with this /24 is this, which is 8, 16, 24. If I go with /24, I will have a usable number of IP addresses. Oh, sorry, I can have IP addresses for my host part 256. If I go with this /24 in a subnetting area. And what it does is it actually changes the number of subnet that I will have only one subnet here. If I increase the number here, number of hosts will increase as well. If I keep increasing it, let's say, from 24 to, let's say, 16, I can have 65K hosts in that subnet. If I, sorry, it is actually decreasing. I'm sorry about that. So if I decrease those numbers in the slashes, number of hosts will increase. If I increase the number here, if I go up, the number of hosts will decrease. Okay. The number of network or the size of the network will remain the same. So what happened is, let me see, what is my next one here? So what happens is, let's say we were given an IP subnet. Now here comes the tricky part. Come on here. Let's say I am given a I was given a subnet 10.1.2.0/24. Okay. Let's say my organization purchased this subnet for me or for my project. And they asked me to carve it out in such a way that I should have, say, 3 subnets here. Okay. They want, let's say they want me to name them as subnet 1, subnet 2, and subnet 3. Okay. Either I do the math on this to carve it out in, into the, into the evenly sized. Let's say they asked me to do it for the even sizes. If time permits, I'll show you how to, do it like, one smaller, one bigger, or 2 bigger, 1 smaller, or something like this. Or we're going to start off with like, 3, same size subnets here. Either I do it manually, or I can, there are, a couple of sites here that actually helps you out here. By the way, these, this slide is for the day 7. It is uploaded to our OneDrive already. So I just click on CIDR.xyz. Is that this one or this one? This is not the one, actually. This is for the IP address. Come on. Subnet. Let's see if this works here. 10.0. What's that? 10.1.20. 10.1.2.0. And it's /24. No, this is not the one. Anyways, I'll pull that up for you guys. So there are a couple of sites that actually helps out finding the like if you wanted to carve out based on that. So let's do this. Let's continue this tomorrow. I'll find the exact site, which is actually anyways, okay. I'm gonna pause it here, and I'll just open the floor for you guys for any questions you have. I'm sure you will have lots of questions today.
Faisal bhai, just to get the questions discussion going, as a cloud engineer, to what degree of this networking knowledge is required or helpful?
So by depends which department you are working with. Let's say you are a cloud engineer and you're working with the network guys, or you're working with the, let's say, with the architect or the capacity team, then yes, you should be knowing this all. But let's say you are working in an IAM area, you probably would not be even hitting it. So it all depends. But if you have somewhat knowledge of it, this networking, this subnetting, this actually will help you out. Let's say you switch the role, or you were given a bigger role to work on that, work in that organization.
Okay, just to sort of add on to that, a couple of things. I'll give you some background in my area. In our VPC, our standard configuration of a VPC entails, let's just say, more than 5 subnets, and each subnet we have designated for a specific purpose. Okay, it's more than 5, and just assume that. One of the deficiencies that we have found in AWS is they don't have a way to detect when a subnet is running out of IPs. We ran into a problem when our auto scaling starts to fail because we ran out of IP addresses in a given subnet.
That capacity monitoring piece is missing.
IP exhaustion is
Yes.
a feature that we have asked AWS to build. So as a cloud engineer, this level of knowledge is kind of important, regardless of whatever role that you can end up doing. Yeah. Okay. I'm not sure if that helped anybody asking questions.
This is the best group we have.
How many of you are still scratching your head as to what Faisal Bhai was talking about, going with this IP address and the bits and all that? I already told you guys, you know, you want the nerd of the century of AWS in a very positive manner, Faisal Bhai. That's you.
Yeah, I think so. We might have to go through this again once to clear our heads and then come back with intelligent questions.
Okay, so tomorrow I'm gonna take it from this point forward because we have quite a lot to cover tomorrow and quite a lot of labs we're gonna be doing tomorrow. So what I'm gonna do is I'm gonna open the floor tomorrow, first 15 minutes, or any questions, any concerns, anything that you have related to the network. Because as we move forward, once we're gonna start doing this, you know, carving out the subnet and then subnets inside the VPC, you will be, you know, I don't want you guys to struggle on that. Let me just quickly show you guys. Where is my console? Just quickly go to my North Virginia. Since you all have North Virginia there. And if I just go in there in services, I'm going to type VPC. You see, if I just click on subnets here, I have this many subnets in VPC. Let me just increase the size here. Sorry about that. What we're going to be doing tomorrow in our lab, we're going to be scratching them all off, creating our own subnets. We're going to assign ourselves a subnet, like a big block of ice, carve it out according to our requirements. And then based on that, we're going to be making some of them a public one, some of them a private one, assign instance, you know, into the public one and then private one, and see how we're going to, you know, go and access them. So this is kind of a very good exercise. And let me just quickly show you guys. And so we'll be just, you know, taking this as an example. This many security groups and this many subnets we're going to be carving out. And, you know, we'll take that point forward. Like, you know, for our VPC, we will have this IP. Subnet 1 will have this, subnet 2 will have this. So we'll take this as an example. And then end of the class tomorrow, I'm going to find something, a very complex one, pass it on to you guys. And then I want you guys to do an exercise, you know, this weekend, so that come next Wednesday, you have a very good understanding. And I'll show you how to do this, like how to scrap the existing one and, you know, how to work on those areas. Okay. So there will be a couple of examples I'm going to be giving it to you guys, because as Kumail bhai mentioned, you never know, you may end up working as a cloud engineer dealing with EC2 instances only, or dealing with databases only. And if you are running out of, if you have no idea how much space do you have in your VPC or that subnet, you're going to be in trouble, because your boss is going to come and bark the orders. Hey, you know what? This many EC2 instances I need, or this many, IPs to be assigned to it, or whatever, right? And you said, okay, yeah, I'm going to get it done. And you will know, hey, you know what? Yeah, that's easier one. When you start working on it and you find out, hey, you know what? I'm running out of IP addresses now. What I'm going to do, how you're going to expand that. So this whole thing, so pay a real close attention to it. And as Kumalba mentioned, so we're going to try that in our exercise, that we're going to assign a smaller subnet, and we'll see how auto scaling errors out if it tries to expand beyond that range. Okay. Okay. Alrighty. So yes. So tomorrow there's going to be quite a lot of VPC work we're going to be doing. I have to cover it all, this whole thing, DNS resolution as well tomorrow, and then lab as well. So yes, quite a bit of work tomorrow. Okay. I'm sorry, what?
This down into tomorrow's class into 2 more classes.
Okay, tell her by 2 minutes.
I'm sorry, I couldn't get your question. You wanted to merge today's class to tomorrow's class?
No, I was saying you probably might have to break down tomorrow's class into 2 more classes.
So we have 2 more classes, but in those 2 more classes, I was planning to cover the advanced area, but we'll see. I mean, if you guys want me to stop or focus more on this network and auto scaling and all that, yes, I can take it in our next week's class as well. But I need at least 1 hour for that advanced area, because those are the things which I really want you guys to, I'm going to give you guys a taste of it, and I want you guys to explore more on those areas. Okay.
Yes, I was thinking probably if this expands more, like if we can have an hour on Sunday or something like that, that might be helpful if you have bandwidth instead of the office hour. Just take this time for that.
The problem with the office hour is not everybody is available to come into the office hour.
Right,
I mean, if you guys are okay with it, I can expand more on it on our office hour. I am planning to run the office hour on Friday, same time. Last time I think I did it for 6 to 7. So this time I'm planning 6 to 8. Give you guys 2 hours.
Faisal bhai, just a friendly reminder about the celebration event.
Yes. I actually.
Okay, I have it.
Yeah, I'm going to be sending an email, and I'll letting them tomorrow. Yes.
Okay. Okay.
Okay. Any other question? Either I shocked you guys, or you guys were not able to hear me completely or clearly. I know that this is being recorded, but I really want you to, I was expecting tons and tons of questions on this. So I know that it looks like an information overload for you guys, but trust me guys, in tomorrow's session, it's like double the, but it is all going to piggyback on what we just discussed here. Alrighty, so then I think I can close the class here, close the session here, and then we'll connect with you guys inshallah tomorrow, same time.
Okay. Khuda Hafiz, everyone.
Jazakallah. Khuda Hafiz.
Thank you.
Office.
Allah Hafiz.